So we want to match this equation here to these points there. So we pass through there. So 0, 6, 129, 296, 3, 379. And those are going to be hard to graph together because of that 6 to 379. So graphing is probably not a good option. So what else can we do with this? Well, let's see. We've got this exponential function. And we are definitely increasing. So it's coming up like that. This right here is like our K, our midline. And then we're oscillating around that midline. So let's assume that we are hitting those points with that function right there. So let's test that part out first. So let's just focus on y equals a times b to the x. And the 0, 6 tells us, so if we think about plugging in 0 here, we would get 6. A times b to the 0 is going to give us just a. So this tells us a is 6. And then we can use this point right here to figure out what b is. So I now have y equals 6 times b to the x. And I'm going to use this point to figure out what b is. So 29 goes there. 6 times b to the power 1, which is b. So divide by 6. B equals 29 over 6. So we're going to test to see if we actually get those other points from this. Let's try that Desmos. So I think, reset please. I'm going to have f of x equals 6 times parentheses 29 over 6, oops, raised to the power x. So there's my exponential. And then I want to check to see if I get these other points there. So 296. So what is f of 2? It is not. Okay, so I made a bad assumption. So let's see. Then, if this is a sine function and it's increasing, what else am I missing? Let's go to the graph or the notes. So what I found was I assumed that the exponential went through these 2 points and it doesn't because I'm not hitting those right there. So my guess then is the exponential must go through these 2 points, and these are maxes and mins. So here we're hitting our midline, the exponential, midline, and then up and down in between. So let's try that version. So incorrect guess there. We still definitely start there. So we know a is 6. So now we have y equals 6 times b to the x, and we're going to use the 296 point. So 96 here, 6 times b to the second power, divide by 6. Let's see, does that reduce? 2 goes into 6 3 times. 2 goes into 96. How many times? Let's see, 2 goes into 9 4 times with 1 left over. 8. 3 goes into 48. 3 goes into 4 once with 1 left over. 3 goes in there 16 times. So I get b squared is 16. So b is equal to the square root of 16, which is 4. All right. And then these other points are going to help me figure out what the sign is. So now I have my a and my b. So y equals 6 times 4 to the power x. Now we got to figure out the c times the sine of pi over 2x. And I should have looked at that pi over 2 right away. So think about that for a second. That's my b. And the period is always 2 pi over b. B is pi over 2. So the pi's are going to divide out. Dividing by 2 is like dividing by 1/2 is like multiplying by 2. So the period is 4. So from 0 to 3 is the first period. So that confirms that here's where I'm hitting the midline at 0 and 2, because 2 is half of the period. All right, should have done that first. Anyway, so now we're going to use the other points to try and figure out what c is here. So plugging in the 1 to this right here, we would get y equals 6 times 4 to the power 1 plus c times the sine of 2 pi times 1, or sorry, pi over 2 times 1, and y should be 29. And let's clean that up. Sine at pi over 2 is 1. So I get 29 equals 6 times 4 is 24 plus c, subtract the 24, and I get c is equal to 5. And that's that last number right there. So let's see if this goes through those points. So I think my function is y equals 6 times 4 to the x plus 5 sine of pi over 2x. And we want to see if we get, for example, 129, 292, 3, 379. So back to our graph here. All right, so we found that that was really just 4. I can leave it in parentheses. And now plus the sine, it's 5 times the sine, pi over 2x. And so here I get 296. All right, that's good. I should get 129 and 379. Check. All right, so we found the right function. And the key is we had to figure out what the period was up front to realize this is a full period. Start, midline, and then oscillation in between. So one full period listed there.